Hello grade 11s, we are in geometry and trigonometry still. We're going to be talking about analytical geometry and specifically lines. Now we're talking about, in this video, application of distance, midpoint gradient and equations of a line. In this video we're going to be filling in the application of distance of a line. It's quite a big section, so we've got it in one video and we're going to fill in something in this box when we're finished. Let's get straight into it. Okay, the distance formula, right? I'm going to start off telling you the distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. It's important to see that we have y2 first, the 2 is first, minus the 1, and the same as for the x2 minus 1. So this is worth remembering. This is your distance formula. Okay, let's move on. The theorem of Pythagoras says, in any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Why do I tell you this? Why is it worth remembering? Just put that there, keep it on the shelf, we're going to get back to that. We have our triangle and our Cartesian plane, and we're going to look at an example. Given the point A, B, and C, determine the length of AC, right? So now we know that A is in 7 and 2. Remember, this is the positive quadrant. X is positive, Y is positive. X is 7, Y is 2. And C is negative 3, negative 4. This is the negative quadrant. Negative 3 is X, so that would be a negative 3 over there, and then negative 4 over there. So here we're going to have a 7, and there we're going to have a 2, right? So why did I talk about the theorem of Pythagoras? In any right-angled triangle, right? In a right-angled triangle, do we have a right-angled triangle here? What if we did this? What if we drew a line across here, just make it a dotted line, and met here? That would be a right-angled triangle. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So the square of the hypotenuse, remember this hypotenuse, is equal to the square of the other two sides. So if we knew the length of this, and we knew the length of this, we could find the length of that. Conveniently, this length here is the change in x. I draw it with a little triangle. Change in x, that's the difference in the x. So that's the same as x2 minus x1 minus the change in y, which is the same as y2 minus y1. Let's carry on. We're going to have AC, that's the length we're trying to find, and that is equal to x2 minus x1 squared plus y2 minus y1 squared. Now remember, it doesn't matter here if that number comes out as negative, it's quite alright, but it is important what the order is. If you're going to say 2 minus 1, it has to be 2 minus 1. Let's continue here. So this is our x1, our y1, and that's our x2, our y2. Again, it doesn't matter what you number that. That could be your 1s and that could be your 2s, as long as you keep it consistent. So here we're going to have x2. What is x2? Negative 3. So negative 3 minus 7, right? And here we're going to have negative 4 minus 2. And that's our y's. Okay. Now we're going to continue. And we're going to say negative 3 minus 7, that's negative 10, quite easy. Negative 4 minus negative 2 is negative 6. Again, now look, this number comes out as negative, but that doesn't matter, it's okay. Because next we're going to have those squared. What is the negative squared? It's a positive, and negative squared is positive. And you know that 10 squared is 100, 6 squared is 36. So that is coming to 136 units squared, right? So it's important to put the units squared. Okay. Let us continue. We have a parallelogram, or we're trying to figure out if this quadrilateral is a parallelogram. So we have D, E, F, G, right? D, E, F, and G. And we're given the coordinates of these figures. You can see that they work. You can work out that that's 15 for X, that's 3 for Y, negative 3, you know this. Okay, so for D, E, F to be a parallelogram, right, so now proving if this is a parallelogram, we know that DG, this number here, this line here, has to be equal to this line here, and we know that DE has to be the same as DE has to be the same as GF, right? So we've got to prove that. How do we prove that? With the distance formula. How can we do that? Well, let's first figure out the distance of DE. What is the distance of DE? It's 15 minus 2 and negative 3 minus 12. 15 minus 2, negative 3 minus 12. What is 15 minus 2? That's 13 squared. What is this? This is going to be 15 squared, and that's going to come out to 394, the square root. You can leave that there. Now, it's important to you don't need to simplify it too much, but if you need to use your calculator here, that's okay. So now let's look at FG, right? So DE has to be equal to FG. Let's have a look at FG. So this is FG. We said x2 is negative 11. Remember, that's our x2 and that's our x1. Again, it doesn't matter your order. So it's negative 11 minus 2, and then 2 minus 13. What happens when you get a negative 13? That is going to be a plus. So that's going to be 15 squared, the same as that. And that's going to be negative 13 squared, which is positive, which is the same as that. And we're going to get, quite easily, you can see, square root of 394. We can tell that these two are equal, right? So DE is equal to FG. But now we need to check if DG is equal to EF. So DG, I've gone a bit ahead here, but GD is equal to, so this is now GD is equal to negative 11 minus 2, 2 minus 12, right? So negative 13 and then 10, and that's 169 plus 100, and that's 269 square roots. Again, leave it like that. Now let's look at EF. EF is 15 minus 2, right? Where do we have EF? 15 minus 2. Negative 3 minus 13. Again, be careful here. That's going to be plus 13. Minus 3 plus 13 is positive 10. And here we're going to have negative 13. And we can quite easily see that those are going to be the same, which is convenient. So DG is equal to EF. And there we can say DEFG is a parallelogram as 2 points of the opposite sides are equal. And we know that that's our proof for parallelogram. And all we used there was the distance formula. Okay, let us continue. Let's have a look at this ABC triangle. It's a right angle triangle because we have this square here. What if we asked to calculate the area, right? To calculate the area, it's half base times height. We don't have those figures, but we can quite easily work them out. Using AC as the base, right? Here's our base. And AB as the height. There's our height. Okay, so the area is a half the base times the height. So what is our base? We said our base is going to be AC, so that is x1, x2, and this is we're going to keep as x2. So it's x2 minus x1. So it's negative 3 minus 2, negative 4 minus 6. Those are both squared and square root. And then we're going to have 8 minus 2, 5 minus 6 square, or the square root. And quite easily we can find our area. Now, here you don't actually need to use a calculator. Now, what was this? Negative 3 minus 2. What is minus 2? Plus 2. So that's going to be negative 1. It's going to be 1 squared. That's going to be 10 squared. We can quite easily see that these equal 101. Now, what is 2 surds that are equal times together? This is going to equal, remember, this is 101 to the power of a half multiplied by 101 to the power of a half. What happens when we do that with our exponents? Well, that becomes 101, a half plus a half. A half plus a half is equal to 1, so that's 101 to 1. Okay, so we can quite easily see that's 101 divided by 2, and that's easy. That's 50.5 units squared. Remember, we've got our units squared. Your answer is wrong if you don't write that. You must make sure you write units squared. As AC equals AB, we can also determine that the triangle ABC is an isosceles triangle. Because these lengths are equal, like this over here, we can also see that this is an isosceles triangle. Let us continue. We have our Cartesian plane. Find the missing coordinate using the distance formula. Right, so we're given this parallelogram, right? We're given the points D, E, F, G. We get told that FG is equal to 10 units. So the length of this here is 10 units. But we aren't given this unit here, this y. So how are we going to determine the coordinates of y? So let the coordinates of f be x1, x2, x1, y1, and the coordinates of g be x2, y2, like we've done here. So we're going to say our distance is -8 minus minus 2, that's plus 2, so 6 squared, plus y minus minus 4, that's plus 4 squared, right? How are we going to work this out? Okay, we know that that was 36. Now y squared, we're going to times this out. Remember, that's going to be y plus 4 multiplied by y plus 4. You can quite easily see that's y squared plus 16 plus 8y. Okay, now we got this big square root here. How can we get rid of that? What if we square both the sides? Square that side and square that side. Oh, that's quite easy. That goes to 100 and that drops completely. We've put our 36 plus 16 to get 52. And we now have y squared plus 52 plus 8y equals 100. Right? Let's make that equal to 0. We bring the 48 to this side. 52 or 100 minus 52 minus 100 is negative 48. And now we just simply got to use our quadratic formula, and you can probably quite easily see that a factor of 48 is 12 and 4. 12 minus 4 is 8. Let's see if that works. Yes, it does. Y plus 12, y minus 4. That's perfect. And we can find our roots. Now, we know that y is in the positive y quadrant. So here we're going to get y is equal to 4 and y is equal to negative 12. But we can see that y is in the positive quadrant, right? All of this is the positive y quadrant. So it's got to be y is equal to 4. Because it's in the second quadrant, y is equal to 4. Okay, well done, grade 11s. That is our application of distance formula. And remember, we've done it a few times in this video. Distance is equal to the square root x2 minus x1 squared plus y2 minus y1 squared. Well done, guys.